I want to thank you for attending today's Forest Industries of the Future Symposium. I'm Scott Harrington with Vanderwall & Associates. We're an economic development, planning, and urban design firm located in Madison. Before we get started, I just wanted to cover some kind of quick housekeeping matters. First, all the attendees except the speakers have been muted, but the chat function is operational. For speakers, thumbnails of your videos do show. So while you're not speaking, please be sure to keep yourself muted. And if you want to turn your camera off while you're not speaking, that's fine too. We do definitely encourage questions using the Q&A function, especially as it relates to the third part of our symposium. And we'd like to keep the questions really focused on challenges and opportunities in developing pathways from research to commercialization versus questions that are specific to the companies and products that we're going to present here in just a moment. However, we are going to provide after this contact information for all the presenters to all the attendees. So if you have specific questions, something that really captures your interest and you want to follow up with one of the speakers, you'll have the contact information in order to be able to do that. We're also going to provide everybody a full list of all of today's attendees, so you can have that as well. And finally, this is being recorded, and we'll send you a link of where it can be found. So if there are other folks who weren't able to make it today that you think would find this interesting, you can forward that link on to them and they can watch it as well. So with that, let's kind of get things started. For more than 100 years, papermaking has been a cornerstone of Wisconsin Rapids' and Central Wisconsin's economy, as well as their social fabric. Unfortunately, the volatility in the paper markets that many Wisconsin mills have historically served has resulted in multiple mill closures over the last 2 decades, including the Wisconsin Rapids Mill in 2020. Confronted with a loss of more than 900 jobs and $566 million in economic activity, the city was awarded a grant from the U.S. Economic Development Administration to identify new sustainable opportunities to diversify its economy and to evaluate various reuse scenarios for the mill property itself. A companion grant was also graciously provided by the Wisconsin Economic Development Corporation to the Heart of Wisconsin Chamber, who's partnering with the city on this project. The city subsequently selected a consulting firm for the project led by Vanderwall & Associates, and also includes the Natural Resources Research Institute that's part of the University of Minnesota Duluth. In the next part of our symposium, we're going to feature some new innovations in paper and forest products. While some forms of paper are on the decline, there is growing demand and interest by consumers and businesses for a wide variety of sustainable products where timber and other biomaterials can be used to replace or reduce fossil fuel inputs. And at the core of all this is the Upper Midwest wood basket. Our region's forest resources are abundant and unique, and we believe these should continue to be economic drivers in the future as much, if not more so, than they have been in our past. The point in presenting the particular businesses and products that will be profiled in a moment is not to suggest that these specific ones should be pursued to replace the paper that was previously made at the Rapids Mill. Rather, we're simply highlighting them as examples of what's happening in the industry today and as triggers for the discussion in the last part of the symposium about the steps we need to take as a region, state, and localities to address the opportunities and challenges in creating pathways from research to commercialization in forest product development. So again, I thank you all for attending and thank you to our speakers. And with that, I'd like to introduce Eric Singsos, Materials and Bioeconomy Research Group Manager of the Natural Resources Research Institute. Eric?
Thank you, Scott. For those who don't know me, I'm Eric Singsos. And the reason I'm involved in this is because I have a long history in the Central Wisconsin region. I was a professor at the University of Wisconsin-Stevens Point for 15 years. And during that time, I worked with colleagues Don Glay and Jerry Ring to develop a forest biorefinery program. And we also co-founded the Wisconsin Institute for Sustainable Technology there. Since in 2016, I moved to Minnesota, and I've been at the University of Minnesota's Natural Resources Research Institute, where I lead a group in materials and bioeconomy research. But I got to know Scott while I was in Wisconsin, and he and his colleagues at Vanderwall and Associates were engaged with the city of Port Edwards prior to this project. That, like Wisconsin Rapids, many will remember, lost a paper mill. And so when they got this grant from the city, Scott contacted me to learn more about what I've been up to in the last several years since leaving the region. And we discussed my role in running innovation platforms for new forest products, and decided that maybe there's an opportunity here for some community engagement around innovation, research, development, and especially translation to industry for economic development. So what we want to do in the first hour is we've selected 5 presenters with some product innovations that are in various stages of development and commercialization. And we thought it'd be instructive for you to hear the kinds of innovations in the forest product sector and where things are going in these specific areas. As Scott mentioned, our purpose is really to focus more on the how of how innovation gets from discovery to invention to commercial development, rather than focus on the specific what of each presenter's innovation. Due to the compressed time format, I will ask people to hold questions until or put them in the Q&A box until the second part, the second hour of our meeting here. And then, as Scott mentioned, we will be providing contact information if you have specific questions about one of the innovations or companies that's presenting here. And then finally, for the presenters, because we do have a relatively short time frame, I think it will be obvious when somebody is getting to the end of their presentation. So when somebody gets to their thank you slide, and you know that you are next, you may want to unmute yourself. So without any further ado, I'll just mention our 5 presenters, and they can introduce themselves a little bit more when they're ready. The first one is Matt Arrow, who works with me at the Natural Resources Research Institute, presenting on commercialization of thermally modified timber. The second is Scott Dion from Timber HP, working on a new timber-based building insulation product. The third is Pat Donahue, who works with me at the Natural Resources Research Institute, but he's presenting on the behalf of a Swiss company, Timbertech, on a new Sbir mass timber product. Fourth, we have Tracy Seville here from Comstock Incorporated, presenting on a biorefinery technology. And finally, 5, we have Addie Teeters from Alstrom Munsko, presenting on some packaging materials. So if we want to advance to our first speaker, I believe that is Matt Arrow.
All right, am I on the clock? All right, thumbs up. Hi, everyone. I appreciate you participating. I appreciate the opportunity to present here today. My name is Matt Arrow. I'm a research program manager of wood products at University of Minnesota Duluth Natural Resources Research Institute. And I'm going to talk a little bit about some of the work we're doing in the thermally modified timber, or TMT, space. So here's my agenda. I'll just give you a really brief overview of what the NRRI is, what we do, and I'll kind of get, after that, the rest of the slides will kind of be getting into the meat of the presentation on thermally modified timber, or TMT. So go ahead. Thank you. So the NRRI, we're an applied research institute. We are part of the University of Minnesota's research enterprise. You can read our mission and vision there. I won't read that to you. Kind of in a nutshell, the way that I look about it, I think about it, is the applied research that we do is focused on how we can better utilize our region's natural resources in an environmentally sound manner to promote economic development. That could be creating new companies, creating new jobs, maybe maintaining existing jobs. So you can see our vision there as well. So we work not just in Minnesota, but we have partnerships around the country and around the world, actually. So the areas that we do research, you can see our 5 main research platforms: ecology, minerals research, materials, and bioeconomy, which is where the work that our team does falls in. And we also work on commercialization and data collection and delivery as well. So go ahead. Thank you. So a brief overview of thermally modified timber, what it is. Go ahead. So in a nutshell, what thermal modification does, it's a chemical-free process that actually modifies the cell walls in wood. In general, what this processing involves in heating wood to up to roughly 220 degrees Celsius. You do it in a low oxygen or a completely oxygen-starved environment. And one of the main mechanisms here is that we destroy some of the hemicellulose in the cell wall of the wood, remove some of the OH negative, or what we call hydroxyl groups. And this is a technology that works generally pretty well with a range of hardwoods and softwoods. So I'll tell you about some of the benefits here on the next slide, please. Thank you. So, so why thermally modify wood? Some of the benefits are you get a decrease in equilibrium moisture content. You get an increase in dimensional stability. So what that means, when the wood is exposed to liquid moisture or high humidity environments, it will absorb less water. So it tends to swell and shrink a lot less than wood that has not been modified. The wood has a substantial increase in fungal decay resistance. You get a reduction in thermal conductivity. So generally the R value tends to go up a little bit. The wood changes color too, it becomes a bit darker, which for certain markets can have a lot of value. So I like to think of it as when you thermally modify wood, you get wood to behave more like a traditional chemical preservative treated wood without using chemical preservatives. So go ahead. So a few pictures of where thermally modified wood is being used now. Some of the main uses. This is a building, I believe this is in Germany. You can see some of the siding on the building in the background. There is also some of the paneling around these garden boxes. Next slide. Some decking, railing, pergola type applications. Next slide. Pool decks. This is, I think, from Holland here. Again, I talked about the really high moisture resistance of thermally modified timber. So having it use an application like this really taps into takes advantage of the performance that the wood has. Go ahead. This is a relatively new building that the Minnesota Department of Natural Resources built a few years ago. And I forget the name of the town that this is in, I apologize. But you can see the gorgeous siding here. They specified thermally modified timber, or TMT, for their siding. Next slide. So some of the work that we're doing in this space here at the NRRI, I'll give an overview. Next slide. And it's important to note, this is not just me. There's a team of folks that I work with at the NRRI and also elsewhere, other universities and agencies. So there's a lot of us that contribute to advancing this research. So a great team that I work with. I feel really lucky. Next slide. So one project that was recently completed is actually led by Pat Donahue, who is our third speaker today, I believe, funded by the U.S. Forest Service. In partnering with Michigan Tech University, we looked at traditionally less utilized or underutilized small diameter timber, which tends to have lower value. And we established performance targets for these species. And these are things like bending strength and stiffness and fungal decay resistance properties. And we made, for the first time, a lot of this performance data public. So next slide. Yeah, so some of the data that we collected here too, and the numbers and the charts aren't important here, just to give you a flavor of the type of work that we are doing here, evaluating the split resistance properties of the wood, the ability to withstand impacts. Next slide. We did accelerated weathering. What happens when the wood is exposed to weathering conditions? How does the wood fade? How does the color change over time? So those are things that we can quantify. Next slide. We work with Michigan Technological University from Houghton, Michigan to do a durability evaluation in Hilo, Hawaii. So we put thermally modified timber samples out in Hilo, Hawaii, which is a very extreme environment, to evaluate what happens to the wood from a decay, a color change, decay standpoint, and also insect attack standpoint over time. So here's some samples that have been out for many years. Next slide. Another project that we're doing that we're relatively early stage is looking at some really simple treatment technologies to improve the color fastness of thermally modified timber, or TMT. One of the big challenges is that when the wood is placed outdoors for extended periods of time, it tends to oxidize really fast, meaning it tends to gray really quick. And we're working on some technology now that has potential to reduce that graying or that oxidation of the wood. So we're doing our kind of what we call our phase 2 research right now. We're advancing that work, and hopefully, if this is ultimately successful, we'd like to potentially commercialize this treatment process that we're working on. Next slide. This is something that I'm really excited about here. We're working with the Washington State University, University of Idaho, Mississippi State University, and some industry partners to advance a mass timber composite made of thermally modified wood strands. This initial work has been funded by the National Science Foundation and the U.S. Forest Service, and I'll have some pictures here. Next slide, please. So this is a technology that can utilize small diameter, low value softwoods that sometimes, or that often tends to have a little value. So what we're doing here, if you follow the arrows, we're making strands, wood strands of very specific dimensions. Next slide. And we're thermally modifying them. This is our laboratory thermal modification autoclave at our lab in Duluth, Minnesota. So we're thermally modifying them. There's some strands that have been, right there. Some strands that have been thermally modified. You can see that color change that I mentioned before. Next slide. And then what we're doing is we're using a very precise, we call a layup procedure to make thin veneers out of this thermally modified strand material. And what we can do is layer those veneers to make panels of a range of thicknesses. So next slide. So here's a thicker member that you can see here of this material. Hopefully later this year, we're going to be doing some fire testing to have some fire performance data, which is really important for a new wood-based building material. Yeah, I think that's probably, maybe I went even a little quick. So yeah, I'd like to comment here too. We do have a patent application filed on this technology, so we're kind of working through the patenting process. So it's a pretty exciting opportunity, and I actually, I think most people here would be just about the first to find out. We will be getting some research funding from the Forest Service starting sometime later this year to develop a similar technology to what you see here, specifically using balsam fir, small diameter balsam fir, which is commonly found around the Great Lakes region and into the Northeast US. So we're pretty excited about that opportunity as well. So those are my slides, and I guess we'll wait for questions until later on. So I appreciate everyone listening. Thank you.
Great. Thanks, Matt. Appreciate your talk. And I believe our next speaker is Scott.
Yeah, hi, can everybody hear me okay?
Yes, we can. Right. Next slide. There we go.
All right, so I'm Scott Dion. I'm the Chief Marketing Officer for Timber HP. Our parent company is Go Lab, and Go Lab was started by Our two co-founders, Matt O'Malia, who is a passive house architect, and Joshua Henry, who's a materials chemist, we're located in the state of Maine. And really what Matt and Josh were set out to do is trying to answer a bit of a question around a contradiction in the built environment. We drive down operational energy use by using insulation that has high embodied carbon. So they set out to try to find a solution, and of course in the state of Maine at that time, which was about 2018, we had just lost 5 paper mills in the state, and we had an abundance of softwood residuals and chips in the market. So I'll just work through the slide deck and tell you a bit about the product line and how dry process wood fiber insulation will be making its debut in the US in 2023. So we'll be producing 3 products: timber fill, which is a loose insulation that gets installed using a pneumatic blower. It can be installed in attic applications or dense packed into cavities. Timber bat, which is a press fit bat insulation similar to mineral wool or high density fiberglass. And timber board, which is an exterior continuous insulation that also has interior applications. And I'll walk through the composition of all 3 products in just a moment. Next slide, please. So dry process wood fiber insulation has been around for over 2 decades in Europe. The largest producer in Europe is Sttr, and there's over 15 manufacturing facilities in Europe. There's actually 4 under construction right now. In the US and Canada, we've had wet process wood fiber insulation, so panel products that are still produced by Blue Ridge Fiberboard and BP. They're really high energy input products, not great R value. Typically they're sold as commodities. What we're talking about is dry process wood fiber, which is really the next generation that offers the full suite of construction insulation. Currently, the market in Europe is about $800 million, and by the end of 2023, with additional capacity coming online, the European market will be $1 billion dry process wood fiber insulation market. Next slide, please. So we actually purchased one of the shuttered paper mills in the state of Maine. This is the former UPM Madison, Maine, the other Madison paper mill, which is on the Kennebec River. It was shuttered in 2016, and 225 people lost their jobs. We purchased it late 2018, early 2019. The paper machine was still in the building. It had been purchased by a scrapper and was being scrapped out, and the equipment was being packaged and shipped over to China. We took ownership while the infrastructure was still in place, so we were able to maintain the electrical infrastructure, steamed, the high pressure steam lines, and there's a natural gas supply there, and we can actually buy hydro behind the meter at this production facility. So we're putting in 3 production lines. We had to raise $135 million to get this project off the ground. We closed our financing working through a pandemic, but we closed our financing in December 23rd of last year. We had an $85 million tax exempt bond that was underwritten by Citigroup, and we had to bring the additional $45 million in equity to the project. We had a Series A round that helped us complete that funding. So when we're at full production, we're putting about half the number of people back to work that used to be employed in this community, and we're using about half as much softwood residuals. Next slide, please. So Madison, insulation is really limited by transportation. So our target market for the Madison, Maine production facility is the Northeast US, though we could transport really anywhere in the US and Canada far less costly than it would be to import the product from the European market. In Europe, dry process wood fiber insulation is manufactured and sold as a premium product. The wood chips there are about 4 times the cost of our wood chips stateside, and energy is 3 to 4 times the price. So where they're selling the product at about a 20% premium, we're able to come in cost competitive, and I'll talk about that in just a moment. But at full production, the Madison facility will produce about $125 million of construction insulation. If you look at the insulation market, just the entire insulation market for the US and Canada is about $14 billion. And if we want to replicate the footprint that exists in the European market, stands to reason that we could have at least 10 production facilities to support the US and Canada over the next 10 to 15 years. And that's really our intent. We're currently, our parent company, we're focused on expansion, looking at opportunities for additional production facilities across the country. So next slide, please. So our product is actually made from the leftovers from lumber production. So we use, softwood, species agnostic wood chips. They just have to be a clean paper chip with low bark content. Typically, it's just those chips that are left over from sawmill production, but also we can use, any small diameter, low value softwood, spruce, pine, fir, hemlock is typically what we see in Maine to produce our product. Next slide. So with cost competitiveness, our 3 products, we're able to come in right in line with the popular construction insulations that we know today. So our loose fill product will be the same price per pound as all borate cellulose. Our board product will be the same price per board foot as EPS foam, a bit of a deduct from mineral wool, and XPS continues to escalate in the market. In our bat product, we're pricing in between high density fiberglass and mineral wool, but it has more, performance merits that are similar to mineral wool than fiberglass. Next slide. So just to walk you through our product line, when it comes to dry process insulation and introducing it to the mainstream market, it really comes down to fire, bugs, and water. I grew up in the industry. I've been in the lumber and building materials industry for 26 years, starting at 16 at the local lumberyard and hardware store. I've been in distribution, sales, and manufacturing. And, when I bring this product to mainstream national installers and distribution partners and retailers, it's always fire, bugs, and water. As soon as I answer all of those questions, then they're like, all right, now tell me more, because I really got their attention. So the way that we produce our first product, timber fill, we just take the chip, we steam it, run it through a plate refiner. We blend in boric acid as a flame retardant, mold and mildew inhibitor, and a pest deterrent. We use half as much boric acid as cellulose because we're introducing it in the wet phase, and we fully saturate the fiber, and then we run it through a flash tube dryer and package it. By introducing that fire retardant in the wet phase, it actually increases long-term performance. We don't have to worry about humidity accessing assemblies and leaching it off that chemical. And the other advantage too is it produces a very clean fiber. You don't have all of that powdered flame retardant in the air when you're spraying it. So this is a Class A product. We tested European product with UL, and we were able to achieve a Class A flame spread. So it's appropriate for residential construction, but also for commercial construction as a fire stop. The R3.8 is in line with cellulose, but we can actually achieve similar R values to cellulose, but use less volume. So next slide. We use that same fiber stream to produce our flex bat insulation. We blend in a bit of polyester fiber as a binding agent, and then we run it through an oven. It's the same process that mineral wool insulation producers use, but instead of using steel slag and basalt, we use softwood chips. We've tested European import product with UL again, and this product performed at Class A. So again, appropriate for residential construction, but also can be used in commercial applications. And a huge advantage of this bat is, unlike fiberglass and mineral wool, you don't have to deal with all of those fibers getting in your skin, or worrying about what you're breathing. The R value is actually higher than fiberglass per inch, extremely dense bat. You don't have to worry about wind washing in the cavity. Next slide. The board product is really just something extremely unique. Tremendous opportunity for this product to scale and actually to ship. We can get far more on a truck, so we can ship it farther distances. So this product is made from a different fiber stream. It's still softwood chips. We steam and refine it. We blend in about 4% PMDI, 1% paraffin throughout the entire fiber stream, and then we run it through a belt press, and we create these homogeneous monolithic boards that are 1 inch all the way up to 9 1/4 inches, with R values that are similar to open cell insulations like EPS foam and mineral wool. It's vapor open, so you talk about wrapping wood structures in foam and trapping moisture and causing issues with rot and decay. You have this board product which allows that indoor humidity to escape, but it's also hydrophobic, so it repels bulk moisture. You can leave it exposed during construction in a roof application for over 3 months, and sidewall applications for 6 months. It's got greater compressive strength than mineral wool, so you don't have to worry about attaching essentially a Brillo pad to the outside of a structure and spend days trying to shim your rain screen. You just fasten it, install the rain screen, and put your cladding on and move forward. So this product without flame retardant performs at a Class B, but we're working on a product that'll perform Class A, but Class B makes it appropriate for low-rise and single-family structures. And we're doing additional fire testing for commercial applications. Next slide. And just real quick on branding, to mainstream this product, we have to lead with performance. So that's really HP ×3. We lead with performance into the market, and then we have an amazing opportunity to talk about healthy people and healthy planet. Healthy people, we don't have to worry about those itchy, scratchy fibers, not putting toxins in our built environment. And healthy planet, this product's fully recyclable, so we could take our scraps, throw them back into production and make new insulation. We can actually take construction waste, that's softwood, chip it and make insulation out of it too. And it's really the only scalable carbon negative construction insulation on the market. Next slide. You look at these insulations to the right, it takes about 8 to 10 years of operational savings to offset the carbon footprints of these insulations, whereas with wood fiber, it lands at the job site carbon negative day one, and you immediately begin addressing issues with climate change. Next slide. And you look at the opportunity for the built environment, driving down embodied carbon in the built environment, and really insulation is a strong number 2, and with wood fiber, there's really no cost premium. Next slide. And I'll post in the chat our videos for the products, and also for our mission video. All of our products will be launching in 2023, starting first with loose fill, and then bat, and then board.
Great, thank you, Scott. And I saw one question came in for Scott on the Q&A, but as I said, we'll provide his contact information for the person who wanted a little bit more information about opportunities in the middle part of the country.
Sure.
All right, thank you. And moving right along, but sticking with the low carbon building technologies, my colleague Pat Donahue would like to present about Sbir carbon sink concrete.
Thanks, Eric, and thanks to the group here, the Wisconsin clan, for inviting us here. And I'd also like to thank Stefan Zolig, the founder of TimberTech. I'd like to thank him specifically for his entrepreneurial spirit to rekindle, rethink Sbir technology. Stefan lives in Switzerland, and we decided it would just be easier if I made the presentation just because of the time delay. But I see he is on the line, so when you're I'm sorry, right? The one thing I didn't do, turn off my phone. Right? Sorry. And so you'll be able to, Stefan will be able to answer any questions that might come up in the chat. So what I have been, well, yeah, that'd be fine, but I'm just going to continue with my introduction. So since 2018, I have been drilling down on what a regional high velocity, high capacity mass timber product might look like. Part of the quest, I was awarded a USDA Forest Service grant. And in 2021, I was awarded a National Science Foundation grant. The NSF grant yielded our TimberTech connection. And recently, TimberTech, in collaboration TimberTech, we've been awarded a new USDA Forest Service grant. Our focus is to conduct a preliminary technical and economic assessment of timber technology, specifically focus on softwood logs, northern softwood logs. So TimberTech, as a Swiss-based company, founded in 1997, the company has grown to multiple locations with an engineering staff of over 70, probably doing some of the largest timber construction engineering for the largest timber construction buildings in Switzerland. And the engineering work kind of spans from residential to commercial and also to other public entities. And the TimberTech has provided a business platform for Mr. Zollig to start and grow other related enterprises. Next. In 2014, Mr. Zollig founded TS3. The technology provides a solution to join mass timber panels and to function as a single plate, providing designers a new choice for mass timber flooring design, and also providing new options for columns and connectors. And most importantly, it really gave TimberTech a global recognition for their timber engineering design skills. Next. We collectively believe that mass timber as a building construction method is here to stay. Finding a solution that can be manufactured with small diameter timber has become our joint research and industrial development endeavor. We believe that the market growth, as the market grows, there may not be enough adequate timber at favorable price points to grow, to keep up with the projected growth. New slide. This is compounded by the larger question, does sawing our regional timber into mass timber grade make sense? Timber products typically, sawn timber products, typically the yields typically range from 30 to 35%. We believe there's technology that this technology presents a better alternative. And even if by any chance a grade can be developed and achieved, sawn timber grade, the question then is there enough availability and is there enough velocity to keep up with the supply chain demands? Next. So scrimper starts with small diameter timbers from thinning operations. And also, it presents an opportunity for plantation wood. Next. The process also has the potential to utilize sawmill residues. However, for our work, the secondary residue option is not within our current scope of work. Next, please. Okay. The process likely originated further back than is typically reported in the literature. It really probably originated through production of bamboo and hemp fibers out of the agricultural industry. The modern scrimper technology was invented in the mid-70s and is largely based, it was invented in the mid-70s in Australia, but it's largely actually based on a patent that was funded, patent developed through work funded by the Tennessee Valley Authority. There quite honestly is no other building material that I know of that has more drama and pent-up expectations than Sbir. The process is simple to understand, but the wide variety of the resulting scrim geometries makes it very, very complex to optimize. So our collective goal, our mission, is to try and rethink and de-risk the technology. Next. Our strategy is to research and refine discriminant methods to reduce, to develop this new long strand composite, creating a hybrid panel product that provides a sustainable structural material from northern softwoods. So taking low grade, small diameter wood and converting into high value structural elements. Next. And the ultimate idea is to develop a product that is a feedstock to other engineered wood manufacturers to convert into CLT and glulam. Next. We have a clear understanding that there will be hurdles and roadblocks. This all takes a plan, and you have to give yourself enough time to be realistic. We know there's a long road ahead, but we collectively believe that the successful commercialization of Sbir technology has societal, economic, and commercial benefits that will enhance the competitiveness of our regional forest products industry. It'll create new jobs, and it will increase the use of wood in environmentally friendly, renewable, sustainable, carbon sequestering building materials. Next. Thank you.
Great. Thank you, Pat. And as others have been doing, you can feel free to put questions for Pat or for Stefan Zola, who I see has joined us, into the chat and connect with them if you have more questions about this technology. Moving on to our next speaker, sticking with the concept of a low carbon economy, but changing gears a little bit, maybe literally, talking about biorefinery to cellulosic fuels, we have Tracy Seville. Tracy. Oh, you are muted, Tracy, sorry. There you are.
I was just trying to follow the directions. There we go. Thank you. Thanks for having Comstock today. And I am standing in for our Chief Science and Technologist Officer, David Winsness, who is far more technically adept at our solutions than I am, but I know enough to be dangerous. And I think to share with you just a couple of our key processes and what we're focusing on. Comstock was formerly a junior mining company in the last 10, 12 years that has evolved in the last few to be focused on two primary areas. So one is battery recycling, advancing lithium recovery technology processes that can be mass scaled and commercialized. So a whole lot of batteries in the world that, and we haven't been able to solve extracting that lithium. It's got a very high value, and it's important to be able to do that for lots of reasons, including environmental ones. And then the other, and we'll call it a globally, and I think environmentally important focus for us, which is the development of exciting biointermediates for renewable fuels. And I am happy to connect anyone with David Winsness following this. I'll put his contact information and mine in the chat after my presentation. I'm going to touch on a few science-based things to share with you today, but I want to give you a high-level view of what really the diversity of our process and what we do with wood and the biointermediates we produce and are now commercializing, with a focus of thinking about where is the industry of cellulosic fuel development. many folks, and Eric's one of them, have been working on looking to solve the problems that have really perplexed all of us in the industry. And there's a few important key, technical and process reasons why the technology hasn't been able to be scaled yet. But really in the last, I think, 4 or 5 years, and Eric would attest to this, I'm sure, some really interesting solutions and advancements have been made. And one of those is the work that Comstock is doing. But really, we're carrying on the commercialization work of everyone who's been working on these solutions, Eric, NRI, and others included. Can you take just the next slide, please? All of this would be preaching to the choir if I were to verbalize it, but David asked me to just focus on this concept of really wood processing industry, as everyone is aware, and that's the reason why we're here, is rapid, drastic changes, but the world is also changing around us. When we think about timber and we think about other natural resources, one of Comstock's main focus is this concept of, industrial decarbonization and what we call short cycle carbon. So while electrification, please, next slide. And you kind of need to click the arrow down. I wasn't sure this was, there you go. Let's start there. We're a company whose vision is net zero solutions. And we're talking about cellulosic fuels, but our focus is on transportation. And in the US, that's, of course, electrification, which is about trying to reduce carbon and fossil fuel. But we won't ever get, far enough to really put a strong dent in the carbon problem in transportation, which is on the combustion side. So we have been looking at this idea that if we can do a better job of utilizing and incentivizing timber to be used for and take it through to renewable fuels, especially if we do it efficiently and we provide a pathway that can produce pulp as well as cellulosic sugar. So we look at transportation and say we can recycle those emissions. And if we did that, if we were to take 10, 15, 20% of the dent out of the transportation burn in the United States and supply it with wood, cellulosic fuel, renewable fuel, we know that's feasible because there's enough, we know there's enough feedstock. Please, the next item. And we know we need to focus on incentives so that we can start regrowing and reharvesting. And we talk about carbon neutrality and our work, achieving carbon neutrality, but really we know that when stacked up against ethanol and corn as an example, we know that we're in the 80 percentile plus in carbon intensity. And so, we're going to keep pushing on those innovations. The most important thing to remember in terms of, the moment of commercialization for cellulosic fuels is that a single biorefinery, based on our technologies, could produce more than 70 million gallons of cellulosic ethanol and 30 million gallons of renewable diesel from 1 million metric tons of woody biomass. And next slide, please. I want to give you a super high level overview of just the diversity of products here. And I'm going to step into a slightly more technical overview of our process, the biointermediates that we're developing, and sort of talk a little bit more about why what we're doing is such an interesting solution for folks in the paper industry. This is, again, speaking a bit to the choir, but what we're really doing is our process is, using the natural extractives and components of woody biomass, and it can be many different types of woody biomass, but we're producing a pulp, mostly cellulose, but our process is also stripping it from a lot of the chemicals and other things that have been problematic for processes in the past. And we're producing, and from that we can produce a cellulosic sugar. That pulp can go to traditional pulp markets, and those products can go to paper products. But the cellulosic sugar can also go to, of course, ethanol, replacing corn. And on the bottom end of that view, the other thing that the other compound product, if you will, that our process produces in addition to the cellulosic pulp is what we call biocrude, and its constituencies, when we process that with resin additives, there's many different product applications and end uses, including, various kinds of siding, plastics. The list is long, and or we take it to what we call Bioleum, which has a lot of the attributes of it's a drop-in product, and we are now working in R&D. Really, it's past R&D. We're now looking at demonstration projects, including been encouraged to apply for the Department of Energy funds to demonstrate the three different pathways I'm talking to you about today, to really show cost efficiency and the conversion capability. So we've been doing this for 5 years at our pilot facility in Wisconsin, but we're now in the next 18 months excited about this next phase of work for us, because here we're working with a very large oil and gas company. We're working with market partners, and the net result of that will be, can we really commercialize this at scale, and what are the economics for other industries such as wood? Next slide, please. This again just is a recap of the process that we're focused on today. The Bioleum, we've just filed a raft of patents in that area, and excited about really the next 12 months. Next slide, please. Could you go back up, by the way, to when you notice one more? There you go. Let's leave it there for just a second. I want to give you a little bit of background. And excuse me, I'm going to refer to some notes so I could be technically accurate. So actually go back down. Sorry. There you go. Focusing on the biocrude. Now our process in the creation of that biocrude, it's reacting, during and after production with various donors to provide, what we call an enriched mixture. And that enriched mixture is the Bioleum. Now, our process is facilitating a pretty positive in situ reaction that produces the biocrude mixture with reduced organic oxygen and increased hydrogen, and that energy content in comparison to known forms of biocrude. So when we're talking about our process, our biointermediates, which is that cellulose, the pulp, the biocrude pathways, those are produced in a mixture of water and various organic solvents without adding any additional corrosive or other chemicals. And the process is happening with a lot less energy and carbon intensity as compared to conventional methods. And we're very much focused on the idea that the process exploits, a divergent natural attributes of cellulose, hemicellulose, lignin, and extractives to sever bonds, to decompose targeted components, and organically react those derivatives that itself forms a mixture of water-soluble, water-insoluble, hydrophilic, and hydrophobic derivatives. We have been working on the, bench, tabletop, pilot batch, and then continuous that takes this pilot process that produces at least these 2 biointermediates to the next scale. And it's the next scale that we're now working on. And those couple of notes I wanted to offer. Yeah, historically, what has challenged the industry here for wood to biorefining and cellulosic fuels is people have attempted to use, they start with woody biomass with fractionated natural lignin or a conventional lignin byproduct such as kraft lignin, lignosulfonate, or I'm going to get the term wrong, but it's organosolved lignin. And these materials aren't really achieving what folks want to in the process, in part because they contain various hydrophilic and other impurities that limit downstream refining. And so our process is also taking those things out of the process before we get to the downstream side. The last thing I just wanted to share technically, but David would walk anyone through sort of where we're at on the science and the technology is, excuse me, just scanning myself here. We look at the market opportunities today. We know that the demand, can you go all the way down to the last slide? When you look at the various feedstocks available in mass today for replacing fossil fuel, we were traditionally thinking about corn. There are other forms of feedstock, fog, fats, oils, and greases. But the demand for renewable fuel development is far outweighs the availability of a lot of those feedstocks. And the one feedstock that we know is a lot of it is available today, but much more of it can be available tomorrow if you incentivize it properly, is the reforestation of crops like willow and other kinds of fast growing trees that could be far more economic for farmers. It could be, the incentives there are pretty tremendous when we look at the economics of the cost from growing those trees all the way through to the development and production of those biointermediates, all the way through to fuel. But this is really our driver. And when we think, when anyone looks at the carbon life cycle benefits of really tree to a gallon of diesel made from wood through a process like Comstock's, we're over 100% in terms of carbon intensity. So we're really in the negative carbon. And we're replacing that gallon of fossil fuel in a way that could be sustained industrially. And so, this is when we look at the view of our world, it's really net zero carbon focused and making sure that we can solve the problems of the technical process. Can you go up one more slide, and this will be my last point. Oh, sorry, back up. My apologies. There you go. Our work in the next 8 to 10 months is very much focused on, we're confident in the demonstration of the science and the technology of the processing. And now we need to make sure that our assumptions for cost and economics all along the pathway are accurate. But when you look at it purely from a greenhouse gas impact and a feedstock cost per gasoline equivalent, the financial incentives are extreme, and we're working with very large scale refinery partners, and we'll want to be talking with increasingly talking with landowners and timber companies and paper companies as we move through this next phase, to make sure that we understand those economics as well. As I said, I will place David and my contact information in the chat. Feel free to reach out to either one of us. And we're open book and really transparent over here. So we're always happy to meet with folks to talk more readily about the challenges and the solutions that we're dealing with. And it's an exciting time. And I think we're finally at the point where real large scale commercialization is finally feasible with wood, renewable fuels. And we're excited about that. Thank you very much for having me.
Thank you, Tracy. Appreciate your time, and we'll look for your contact information in the chat. Our final speaker is Addie Teeters from Alstrom Munsto, which I still
You were
struggle
super
with.
close. Super close.
Again, sticking with the sustainability message, in this case, displacing plastic. Go ahead.
All right, so I am going to completely pivot the conversation here and start talking about the ways that our organization and the paper industry can have a significant impact on plastic replacement solutions, replacement of non-renewable solutions in the marketplace. And we're doing that all with fiber. So as it was alluded to at the beginning of the presentation, the industry has gone through a lot of recyclability of its own, and many of our products in the global paper industry have been replaced by electronic media as such. I will say, in terms of the packaging industry, in terms of food packaging, e-commerce packaging, we are starting to flip to being on the right side of history here. And that is through fiber-based solutions and renewable solutions. So really what I'm going to do today is just sort of highlight for you broadly just a small bit of those products that we're really highlighting and we're focused on, and then give you a bit insight into our process, into our product development process. So as was mentioned, I'm with Alstrom Munsto. We're a global organization of about 45 plants across the world. We operate in 14 different countries, and we have about 8,000 employees. But right here in the state of Wisconsin, where I am, we've gone through a lot of name changes. So you might know our plants as Wausau Specialty Mills. You might know our plants as Sbir Specialty Solutions or Tillmany Papers. And we have 4 manufacturing plants in Wisconsin in Rhinelander-Mosinee, Kaukauna, and De Pere, and we have about 2,000 employees in the state of Wisconsin. So we are really proud of our Midwestern roots. So go ahead to the next slide here. So again, as I alluded to, really what we're seeing in a shift in the marketplace, consumers and brand owners definitely are demanding those more renewable solutions. So many brand owners, so many companies, all of us, we have our own sustainability goals, net zero goals, whatever those look like, and replacing a non-renewable solution in terms of a package with a renewable solution can oftentimes really get those brand owners to meet their sustainability goals that they're looking for. And consumers want the guesswork out of that end of life story. They want to know that when they have that package in hand, they can easily recycle it. They can easily throw it in the compost pile. And so it's really on us as paper manufacturers, as forest products folks, to try to figure out what do we need to do to innovate and get people to those goals. So what we've developed in about the last year or so is our From Plastic to Purpose campaign. So we are really trying to raise awareness all the way through the supply chain about what are the types of renewable packaging solutions that can be offered through a fiber-based solution. And we're doing this, if you want to hit to the next slide, we're doing this in so many ways. So this is kind of an example of our philosophy here. So you can see we're aiming ultimately at raising that awareness of the possibilities. And the education is really key to this. So we're encouraging our customers, the marketplace, to all consider fiber and paper-based solutions when they are innovating those products for their customers. And we want to utilize a collaborative innovation process. So you can kind of see with this philosophy tree here, clearly there's development and trials. We have to work with the entire supply chain already, starting with those loggers and landowners. But then we have to continue to innovate and make sure that we're talking to the right marketing folks in the supply chain. What are we doing with sustainable branding opportunities? For instance, are there sustainable brands that want to work with us? The other part of this that I'll call out is the consumer education. So we have, for instance, received feedback through case studies in the past where, for instance, we replaced a chip bag with that traditional like potato chip bag that has the foil or it has the film and you open it up and you eat it. We replaced it with a 100% fiber-based solution, and we received feedback from consumers. Well, it sounds different when I open it, or it just feels different when I open it. So we have to start educating consumers to say, we understand that it might act a little different. A paper straw is certainly going to feel a little different than a plastic straw. But if we want to have a more positive end-of-life story and reduce our impact on the environment, we have to challenge ourselves to be okay with some of those differences. And of course, there's the entire scope around what is that end-of-life story. We want to make sure that all of our products fit somewhere in that positive end-of-life story, whether that be recyclability, compostability, or of course, just end-of-life biodegradation. So next slide. All right, so here is just an example of some of our many, product offerings in terms of those plastic replacement and non-renewable solutions. So if you hop right away to the next slide, I'm going to try to make up some time here for y'all. So Crystal transparent packaging, this is a great example of an evolution of different transparent papers that we are manufacturing. It's 100% fiber-based, but it has this fantastic transparency level. So when you think of all of those spaces where you have almost a complete fiber-based package, but yet there's still some sort of a plastic or there's still some sort of a film on it, we have the ability to replace it with this more transparent solution. Additionally, we have received compostability certification on this product and also recyclability certification. But you can see right there, and I think all of us can think of it, if you're a true recycler, you probably have that pasta package that has that little plastic window in it and you're pulling off the plastic so that you can recycle the box. This takes the guesswork out of it for the consumer, and then they are allowed to recycle or compost that entire package. So go ahead and go to the next slide, para-free. So this is a technology, but it's also a paper for us. And again, it's wax alternative. Think about your deli sandwiches that you're getting from any of the major chains. So many of them are moving to this type of a solution where it's a paper that still offers grease resistance. It still offers water repellency, but it is not treated with wax. So therefore, that means that whether that product ends up in the landfill or whether it ends up in the recycling bin, it has a positive end-of-life story. Whenever you try to take a fiber-based solution and you over-treat it too much with some of these other properties, then of course it takes the compostability requirements away, or it takes the recyclability components away. So this is a really awesome opportunity for us to, we're continuing to get it out in the marketplace and just make sure that, again, we have the ability to create these papers that have these inherent properties of grease resistance, water resistance, what have you, without treating it with a lot of extra stuff. All right, next slide, pure barrier. This is a very interesting one that I think will get everybody thinking a little bit. So obviously, we have products that have been traditionally covered by a plastic or a non-renewable solution that creates an oxygen barrier, a gas barrier, sometimes moisture barriers. And here's a prime example where we have been working with some, strong coffee manufacturers to replace that plastic lidding over the top of a cup of a capsule and to make sure that it's 100% fiber-based. Again, this is an example where these manufacturers are taking a look at their full product offering and trying to figure out how do we make it better without disturbing the product and without disturbing the process. That's always the big thing, is whether it be one of our converting partners or an end brand owner, we want to make sure that our products, if we're changing it to a fiber-based solution, it's not affecting the process, that manufacturing process. And another little interesting note about that last product, it actually has heat sealability properties as well. So without additional treatment, you can heat seal it as well. Next product here, this is really exciting for us because not only are we continuing to replace the multiple layers of a pet food bag. If any has pets, you know that when you open that pet food bag, there's multiple layers to it. And it's because not only does it have to have the strength of keeping that very heavy kibble intact, but also it has to be grease resistant. That's a very greasy type of an application. So we are working with many major brands right now to replace non-renewable packaging, to replace that plastic and that film with a paper-based solution. But the other side of this that we are working on is grease resistance without the use of traditional chemicals. So people might be familiar with the term PFAS or fluorochemicals. Those are traditional chemicals that have been used in the industry and were FDA approved to treat paper products and make them grease resistant. The pet food industry is really moving strongly away from that, and we're supporting them because we have figured out how to apply technology and through the refinement of our manufacturing processes in order to create grease resistance without the use of these chemicals. So again, it's a huge movement. People, of course, love their fur babies, and they want to make sure that their kibble is in the most safe, chemical-free product possible. But also, once again, we can take that guesswork out for the customers and have them move that bag immediately into the recycling bin when the pet food is gone. Next slide. So actually, if you want to skip right ahead past this slide, Sonia, let's go to the next slide. I'm going to show you all just a couple of examples of some technical applications where you might not even consider a fiber-based solution would be included. So our Octalum RFID release material, really, really exciting stuff. It's a pre-laminated inlay. And so what it does is it goes into the inside of, for instance, your pass, your key that you would go use to get into your work building. It's actually used in chips and credit cards, and it's made from 100% renewable and sustainable raw materials. And it's designed to really be used in that end use lamination press process instead of a plastic film. So again, such a small little application, but a way that we're continuing to make an impact in the industry. And next slide, this is another just big call out that I wanted to have everybody keep an eye on is e-commerce packaging. So with the pandemic, of course, we saw the need for e-commerce packaging and delivery go up significantly. And so our business was really prepared and ready to pivot for this. But again, I believe all of us have received those boxes and those packages in the mail where you're literally taking out all the plastic and you just don't know what to do with it. And so then it ends up in the landfill, quite frankly, it ends up in your garbage. What we are doing is working with e-commerce manufacturers to really redo the entire process. So you'll see the graphic up on the top. That includes cold chain technology. So for meal delivery, for anything that has to come with medicine or cold packaging, we have the ability to do that now with 100% sustainable materials. Even down to the tape. So our plants here in Wisconsin, we make a water activated tape that goes 100% into Amazon products. So even though that Amazon Prime tape gets a little tricky when you're trying to open up that box, know that it's being made here right in Wisconsin, and we have worked with them to make it 100% renewable, fiber-based. So again, taking that guesswork out for the consumer so that if that little bit of that tape is left on that box, it's okay, it's going to be able to decompose and be used in the recycling process. Some other areas where we're really focused on too with e-commerce packaging is protective envelope mailers, making sure that we can still have that padding and that cushioning in there without the use of plastic. Void fill, we feel like that's a very easy area where you're just trying to take up space. Again, we have our lower base papers where we can do that. And of course, there's also just a consumer preference and diverse packaging component to this, where we have the ability to work with brand owners to really have that distinctive branding on the end use packaging, making sure things are 100% chain of custody certified from our Wisconsin forestry products, but also just to make sure that when the consumer gets that, they know that they're receiving a renewable product. Next slide. Here's an example too of one thing that we're just continuing to educate our consumers on and our converting partners is the fact that our Wisconsin mills are 100% integrated with natural products. So if you want to just, for instance, try to find a product that's a little bit more renewable, oftentimes moving to a natural product as opposed to a bleached product is a way that people can support that. And again, we feel really strongly about our Wisconsin forest products industry, and all of our plants are triple chain of custody certified, and we really work strongly with our loggers and landowners to make sure that we're continuing to just really hold true to those sustainable forestry practices here in the Midwest. Next slide. Just a final slide here, just to kind of remind you all, I think for the most part, inherently, everybody understands this. I guess folks on this call probably do, but one thing that we've really seen with our customers is sometimes they're asking for a biodegradable product, but they're really not quite sure exactly what they're asking for. What's the difference between biodegradation as opposed to compostability, as opposed to recyclability? So this is an area where we're just continue to focus on, especially here in the Midwest, to try to challenge our our regions to say, what are we going to do to put more composting facilities in place as opposed to landfills? What are we going to do to try to make the recycling stream more user-friendly for the public? But sometimes the first part of that is to make sure that our customers know what they're asking us for. Are they asking us for compostability certification all the way through the end use package? Or do they just want to know that this product is going to eventually degrade in a landfill environment? So we're just trying to get the education out there. And I think it's on all of us as consumers to make sure that we are challenging our waste services, that we're challenging our municipalities to say, what resources do you have for us to make our regions just a little bit more sustainable? All right, and just to wrap here again, what I'm going to do in the chat is I'm going to put an actual link to our campaign page from Plastic to Purpose, and follow us on this journey. We're doing a lot of exciting things to continue to push the boundaries in terms of what are we doing to create those plastic replacement solutions out there in the marketplace. And I think everybody can just have all of you who are from the Midwest have a little bit of pride to know that the Wisconsin paper industry is still strong, and we are contributing to a better world with some of these products. So thank you all.
Thank you so much. Looking at the time, I appreciate Addie. I appreciate all of our speakers. Looking at the time, I think we are going to pivot now quickly to the next section of the meeting, and that is we're going to have a little panel discussion. What I wanted to give everyone the reason I wanted to give everybody a taste of some different and new innovations in forest products and from paper to building to fuels, all of which are started with a process of innovation. And the innovation process never happens by itself. There's always partnerships and resources available. And I've invited 4 panelists who play a role in the innovation pipeline in the state of Wisconsin. And what I'd like to do is I'll give them, if you can all turn on your cameras and microphones, I'm going to give everyone a brief opportunity just to introduce themselves. And then I have some questions, or we will take some questions from the audience about what resources are available and how we leverage those resources to innovate and create economic development for our northern Wisconsin and regional communities. So without further ado, I believe the first one is Idella. Would you like to introduce yourself and the Center for Technology Commercialization?
Hi, everybody. Thank you for having me. And I will say I've enjoyed the first hour of presentation. So I hope we can add some value here in the second half of this conference. So my name is Idella. I am the director of the Wisconsin Center for Technology Commercialization, or CTC. We are a program that is a free resource for Wisconsin businesses. We are funded mostly by the Wisconsin Economic Development Corporation, and we are housed within the University of Wisconsin system, providing services for the entire state. And we are primarily charged in supporting businesses to access federal innovation funding through the Small Business Innovation Research Program, or SBIR program. And there will be a set of collateral slides that I sent in that I think will get sent out after this, so you'll be able to see these things in more detail. But if you're not familiar, the federal SBIR program and its sister program, Sttr, is right now about a $4.2 billion program that encompasses 11 participating agencies, which I'll just mention 2 or 3 that might be interesting here, maybe 4 actually. The Department of Defense, which are also looking for renewable and sustainable resources, the National Science Foundation, USDA, and Department of Energy, I think were some that were mentioned here. Those are 4 of the 11 participating agencies in the federal program. The reason that we exist are to be Sherpas on behalf of small businesses interested in pursuing this. One thing that I always want to dispel is that the SBIR program is a program for small businesses. It's awarded to the small business. Now, small business can work in collaboration with other small businesses, with larger businesses, with university resources, but this is a way to support and develop innovative research and to commercialize those projects. And so What we do is we help you to develop a strong grant or contract proposal for any one of these 11 participating agencies. How are you eligible for the SBIR Sttr program? Well, in general, the program is available for what the SBA terms as small businesses. So anything under 500 employees, which are many of our Wisconsin small businesses. You do have to be primarily owned by US individuals. There are some other rules about size and other things that are just too difficult to get into at this place, but that's why we're here to kind of help you to navigate if you can be eligible and what agency and what topic might be a good fit. And most of these opportunities, many of these opportunities require a document, a scholarly document, a proposal that goes over what you're going to do with your research and development plan and how you're going to leverage that research to commercialize activities. And so it's a really great fit for a lot of those that I heard on the call today, looking at cool new projects and really interesting and tough spaces, solving very important problems. And so I would invite you to reach out and learn a little bit more about us. One way or a number of ways that we help you to get to that end goal for a strong, competitive proposal is we have a number of different programs that range from introductory to the SBIR process, a small accelerator to help you to prepare a grant or contract submission. We offer pre-submission panel reviews where we bring in experts that will help review your proposal before the deadline. And then, of course, one-on-one consultation. All of us are scientists by training. We've worked in business, and we bring those skills to the table to help you submit a competitive application. We also manage some matching grants on behalf of WEDC. So if you do get an SBIR award, these funds fund mostly the research portion of it, but there are definitely business activities that you have to do. And you can apply for these complementary or matching funds to help augment your federal SBIR award. And these too are grants, so non-dilutive funding for your business. And then lastly, we do manage another seed fund opportunity called the Idea Advanced Seed Fund. It's a little bit different in that it does fund and help you to support and work through the business risk around a new or innovative project. It's a great fit for new businesses, but we've also expanded it to work with existing small businesses. It just so happens the deadline is today in about an hour and a half. So it would be something to look forward to next year if you might be interested. And lastly, we know that this process and these programs are interesting, but can feel overwhelming. And so we've used the tools of videos and created a number of on-demand resources. We try to have a pretty active social channel through LinkedIn and Twitter and others so that you can hear from us on demand on how to think about, prepare, and compete for these sources of R&D dollars for your business. So I look forward to answering any questions and telling you a little bit more about what CTC has to offer.
Great, thank you. Next, Arjun, would you like to give yourself a brief introduction to yourself and WISES?
Thanks, Eric, and I appreciate you inviting me to participate in this panel. It was great to, I only got part of the presentations, but it looked really good. Can you see my presentation?
I think if you don't mind, we're not going to switch to your slides, if that's all right. Can you just give a verbal introduction?
Okay. Give me a second here. Yeah. So WISES is a 501c3 corporation that's a supporting organization of the UW system. And if you think of what you just heard from Idella, we're at an earlier stage in the process of working with to empower researchers, inventors, and innovators and entrepreneurs. We connect them to solve with industry partners to solve problems, and we build a pathway for the solutions that they have to get to the marketplace. WISES is, the 11 regional University of Wisconsin campuses we serve around the state include UW-Oshkosh, UW-Green Bay, and UW-Stevens Point in kind of the northern part of the state, northeastern part of the state. And, you know, one of the things that our schools have been recognized as #2 nationally in innovation, impact, productivity. So it's something that, you know, we take pride in kind of supporting, you know, the creation of intellectual property, the protecting that and helping to get that from, you know, our institutions in partnership with industry partners out to the public. One of the newest programs that we've been working on, it's called WISIS Venture Home. It's a network of startup hubs where each venture home is a partnership between WISIS, the campus that we support in its community and its local community. And the idea is to bring together all of the resources that exist in that community under one roof, and to make sure that, you know, an entrepreneur in that community has the resources and connections to be able to make their startup work. And the other key concept about the Venture Home Network is to not duplicate programs that already exist, but rather to create a structure to be able to connect all of the things and make it very easy for people to connect to those things. So we think of kind of this network effect where we're connecting local ecosystems to each other to learn and work together to support local entrepreneurs, and then connect within the University of Wisconsin system to facilitate mutually beneficial relationships between these experts and local talent, and then increase the influence and confidence of startups in our local communities. So, you know, we've worked with Eric in the past. He was one of our inventors. And I think, you know, WISIS is an organization that, you know, really has a lot of tools to support the development of the technologies and kind of think about how do you know, put those pieces together to make a scalable company or opportunity, or find an existing company to be able to connect with and have them take a technology forward. And then how do you build those partnerships with our faculty and our students to be able to, you know, work on some of these new and innovative ideas.
Great, thanks, Arjun. Next up, Masood, and just a reminder, we'd like to at least 30 minutes for discussion, so we'll be quick.
Well, I'm going to be pretty quick then. So,
thank you.
All right, well, my name is Masood Akhtar. I'm located right here in Madison, Wisconsin. Well, you know, I have two companies. One, I have a number of companies, but this is one of them. And so when we look at different industries all across the globe, we look at two ways: how to make them more competitive, more sustainable, and more revenue generating. So we take the approach of reducing energy in the pulping process. I'm going to focus just on pulp and paper, but we focus a lot on other industries as well, just because that's the topic for discussion today. And so we provide technical expertise, subject matter expertise, and other opportunities as well to make sure they remain competitive and reduce the energy. The second part is how to generate more revenues, and that's what this particular company, Biorenewable Deployment Consortium, is. That has all national major pulp and paper companies and overseas companies part of this. And the focus here is that how to bring those technologies for deployment. We don't focus on research, but look at the technologies and take it to pilot and all the way to commercialization to produce biofuels, biochemicals, and bioproducts from wood waste and other types of material, including recycled material as well. Particularly with focus that does not require any kind of long-term subsidies. So focus a lot more on brokering partnership, bring all the partners together, do due diligence, and make investment from the private sector into this. So project size of investment that we have been involved with somewhere around $5 million, all the way to $1 billion project. Trying to replace that. The membership also include a lot of chemical companies as a part of this as well. So the way we look at it is just to look at from both the sides of reducing the cost of manufacturing of what they are making and generating additional revenues. And that's how we believe we can revitalize the forest products industry. Well, that will give you enough time, Eric.
Yeah, thank you. And then we have Melinda from WEDC.
Thank you, Eric. So I'm Melinda Osterberg. I am a Regional Economic Development Director with the Wisconsin Economic Development Corporation, also known as WEDC. WEDC is the state office charged with economic development. I'm part of the Business and Community Development Division. So what I do is I assist businesses and communities in the central part of the state. My region goes from Lincoln County in the north to Adams County in the south. So obviously Wisconsin Rapids and Wood County is in my area and where I serve. WEDC also has other divisions that assist with entrepreneurial development and international and innovation, global trade and investment. So as you heard, we do fund organizations like IDELA's. We are funding this planning process. Basically, when I do this talk in person, I ask people to name a large project that they know of in their community. They will name it. I will say, yes, we contributed funding to it, because most times we've been involved in some fashion in most economic development throughout the state. So I look forward to the panel discussion.
Great, thank you. And please, everybody, if you want to, if anyone in the audience wants to put a question in the Q&A box or in the chat box, I can try to work them in. But I'll get started with the panelists here. And give you a tough question. I mean, we've seen the city of Wisconsin Rapids, and as I mentioned, other cities in Wisconsin, Port Edwards. We saw our colleagues from Maine, and we certainly see this in Minnesota, where a paper mill goes down, you lose hundreds of jobs, and there's a reaction of resources to try to make things better. But one of the reasons I have this group here is we have a lot of forward thinking, a lot of new ideas, and perhaps an opportunity to be proactive about it. So somebody can jump in, or I'll put somebody on the spot. What do you think about what does a proactive versus a reactive approach look like to maintaining resilience and sustainability in this sector?
So I can start if you want, Eric.
Absolutely.
I wrote an article about this in Post Crescent many years ago, and my title was "The Pulp and Paper Industry Should Be More Proactive Than Reactive." And here's the reason why I wrote that article. Because I saw pulp and paper companies were shutting down, and then all of a sudden I started seeing the discussion about, hey, don't shut it down, I will write you a $100 million check. Hey guys, what's going on here? Let's sit down and talk about it. That I thought was a reactionary approach. So that forced me, when I was seeing that, oops, that's really not the right strategy. We need to be sitting down with our paper companies at very early stage and talk with them about what are their needs, both short-term and long-term. So I wrote an article and I said the way we should do that is manufacturing is so important that it should not be dependent on one party in power. So what we need to do is we need to create a Wisconsin bipartisan paper caucus where we can have elected officials of both parties. And then we have our stakeholders, pulp and paper companies and economic organizations, working together, meet together quarterly, regularly, and then talk about the short-term and long-term goals. And that, we launched that. We have elected officials of both parties. We have the president of Wisconsin Paper Council. We actually also have a governor designee who is the chair of Wisconsin Economic Development Corporation on that as well. So I think that if we do that, and I'm promoting that model now nationally, talking to other governors in other states, So I think that to me is the first starting point, is bringing these people together and be more proactive than reactive, and do it in a way that is more bipartisan in nature.
Yeah, great answer. And I guess I would look at it, this is Arjun Sangha, I'm the president of WISIS, and from a more of a practitioner standpoint and kind of where we're coming from it at, and you talked about kind of the disruption to the communities. And I think that, you know, the program that we started, WISIS Venture Home, was exactly to address things like this, that what I think we need, you know, communities like Madison and Milwaukee have a lot of tools, a lot of programs. Big cities have a lot of programs to support and help entrepreneurs and help bring people together to think about innovation and new companies, and how do you bring those things together. I think that one of the challenges that we have in the communities around Wisconsin, especially the ones that WISIS serves in those smaller communities, is that they have some good tools, they have some good industries, but they don't have all the tools. And so how do you bring all, you know, how do you fill in those gaps? And I think that kind of building and thinking more about the support network that kind of gives people that opportunity, one, to know where to go and, you know, congregate with others that are thinking of these ideas, and then have a real intentional place to be working together on these new ideas. I think that that's the kind of thing that we're thinking about, and then having that, you know, easy ability to bring these industry partners connected with all the talent that exists at the universities that are spread around the state. That there's this tremendous pool of talent, and we need to kind of tap into that. So that would be my thought, Eric.
Excellent.
I'm just going to extend it by just a small point, and that is to extend the practitioner point of it, is that I think first off, it's wonderful to have the self-identified entrepreneurs in the room. But the opportunities can come when you reach out and bring in those who may not have self-identified, those who may not know about the challenges and the opportunities and the growth and the innovations that are in the sector, who the players are. And so opportunities that might mean experiential learning, that might mean working with smaller businesses that are in the ecosystem to support training and development, conversations with technologists that might think about innovative ways of integrating some new technologies into some legacy industries. And then I think one of the challenges that I see often on our side of the table is that you might have really innovative, interesting ideas, but pursuing the kind of funding that would help move the technology forward, right? They're technologies, they're not necessarily products yet. And so it takes a lot of work to move those forward, and being able to create the space for the technologists, the potential inventors to pursue the kind of funding and the rigorous work to go after some of these research and development competitive dollars. So what space we get to create to go out and look at those proactive opportunities versus being consistently reactive is a real challenge for all of us.
I think at WEDC, we've done a good job of, assisting existing companies with expansions and retrofits as they see fit, and then also funding that entrepreneurial ecosystem throughout the state. So that's kind of how, I think it's kind of a two-prong approach. One, how do we support our existing companies? And then also work with entrepreneurs as they grow their businesses.
Good. I have an excellent question from the audience here. Ownership time horizons is a major issue, especially in natural resources industry. It can take 30 to 70 years to grow trees to harvest. We need owners with a long-term time horizon Private equity firms that want to own and dispose of ventures quickly is often not a good match with that business. Could we talk about some ways to foster company ownership with a more of a long-term time horizon?
I'm gonna lean on Masood first.
Yeah.
Well, we are dealing with all these, national companies. We brought a lot of international companies, and they are taking waste material, plastic, converting into biocrude, you name it. And money is out there. I guarantee you that. The issue is the nature of our industry, very risk averse. So the way I have been dealing with our industry nationally, internationally is I'm telling all of these technology companies, do build, own, and operate type of model where private investors believe in equity investment. Equity investments are long-term. They know they're going to invest in 10 and get return on 1, but that 1 would take care of all the 9 that they lost. So all the companies that we are working with, we're talking with them all the way, develop the technology, do build, own, and operate models. So we go to the pulp and paper industry and we said, look, this is how it's going to help. And it costs about $50 million to do it. And by the way, this is your waste material. Cost to you is 0. You just give us something, and the revenues that we're going to generate, we're going to share profit with you. So I think this is the approach that I am taking with all of these things, whether it is reducing their energy at a larger scale or generating more revenues. So for example, in pulp and paper, you have a black liquor, you have a lignin you burn, and everybody says, you can make everything out of lignin except money, but that's no longer true. A lot of these companies are coming out. We're working with one company in Europe from Finland called Medgen. They take that lignin out, they put their enzyme in it, convert into value-added products, many applications. Pilot facility is $12 million. So we are funding that. The commercial is 100 million. We are funding 100% of that. And then the industry is very interested because they're burning it. Now they have this kind of opportunity. So it will take a lot of resources, a lot of those things. I think the role that the federal agencies are playing into this is also pretty significant. One project we got involved, $180 million from DOE to do these 2 projects and that. So money, I think, is available. You just have to have the right fit, and you have to have the right host site where these things might happen.
Yeah. So I want to give everyone else a chance to talk. Otherwise, I'd like to build on that, or kind of connect a couple of points, maybe. Because there's some really interesting technology and technologies, and Arjun and Idella in particular work with early stage technologies. Maybe an entrepreneur who's a small, developing a small business, but there may be a good fit with some of these larger legacy industries. Are there any tools that can be leveraged to maybe get somebody in the door, or do, like you said, work with our paper industry or our forest products industry to do a demonstration and do a kind of a first commercialization as a partnership?
So are you asking, are there tools available to make those things happen? Or
Yeah.
Yeah, I mean, I'm going to plug SBIR, of course, as a tool to kind of make that happen for sure. I mean, there's one of our favorite USDA success stories is Whole Trees, and they very heavily leveraged the USDA SBIR program and partnerships with Forest Products Labs to kind of bring their innovative technology to the market. So the nice thing about the program, the federal program, is that you can have more than one SBIR. You can cover multiple components of your innovative technologies. The challenge is being able to write a good proposal. And so when Masood mentioned DOE and that, big financial opportunities, the thing that really challenges applications are bad grantsmanship. And it's a skill. And so, Arjun has a grant writer and a grant writing development program. That's something that we do consistently at CTC, is to help you think about and write these kinds of grants. They're not research grants in the traditional sense. And so it does require a different act of going after that. And then there are really cool tools that the federal government uses, CRADAs, OTAs, and other contracting tools so that you can do business with other nonprofit research institutions. And so they create some rules and some strategies so that you can go after these partnerships to explore if the invention can truly be innovative. And by that, I mean, can the invention really be used in a value added use case way? And so the nice thing about Wisconsin is that we do have these free resources to help you bridge that gap.
Yeah, thank you. And thank you, Adela. And I think that, you know, I talked a little bit about it in the introduction, but, you know, to kind of expand a little bit, that, you know, WISIS is kind of a window into all of the great research that's going on at our regional comprehensive campuses. And they have, you know, different campuses have expertise in areas. We certainly have a strong area in the forestry industry and related kinds of things. And so there's real opportunities to collaborate with faculty that have those areas of expertise and interest. And if you can find that and we can help facilitate those, we have internal, not only support like Adela was talking about, and then down the downstream kind of pursuing SBIRs or other external funding, but internally we have a program called the Ignite Grant Program, where we can provide our faculty with up to $50,000 to work on a project that has some economic development significance in Wisconsin. And so that's an opportunity to partner with industries to think about new technologies and ideas and think about things that are kind of long-term. So there's you know, various programs that we have to try to make those matches. And I think that our regional campuses are well suited for this because they tend to do a lot of applied work, right? They tend to do more work that's trying to work on the problems that industry partners are trying to solve. So.
Good. Thanks.
Mm-hmm.
I have a comment and a question from the audience. First, the comment, you know, business research is certainly required for sustained long-term sustainability of the business. And clearly that's the legacy of the Consolidated Paper, the owners of the paper mill before Stora Enso and Verso. But you know, that's, you know, some of that's fallen by the wayside with a lot of our legacy industries. How do we structurally support internal research? Here's the question from the audience, and maybe I'll add my question to that is, you know, how do we structurally support research between research collaborations between industry and the university, or industry and maybe those small budding entrepreneurs, you know?
Yeah, let me take a stab at it, and I'm sure others have their points as well. And I think that I just, to kind of follow on with what I said, you know, WISIS has some internal funds, they're modest, but I think that there's, you know, we're seeing more collaborations between our campuses and industry partners that have kind of an area that makes sense for that campus. For example, in Eau Claire, they've created a really nice partnership with the Mayo Clinic, and they've got programs that are associated with that. So I think that there's opportunity at a high level to try to work with a particular campus and see if you can structure something like that. I know that Idella and I have both put in concept papers to the NSF engine program, and there's others within the state that are doing that as well. And I think that, you know, you know, this is just the beginning of that, but that would be another way to, you know, if we can kind of bring those things together and, you know, get the, you know, the phase one of that, and then plan to bring some of these ideas under the phase 2. There's a real opportunity to create an environment to be able to structurally fund a lot of things, within Wisconsin that could support, doing some really interesting research in the long term that leads to commercialization, because I think that that's exactly what the NSF Engine program is about.
Mm-hmm.
I mean, there are like fintech and biotech and other industries, insurtech. They have really put forward a model, and we can always make them better because they're not 100% home runs, but models in where they have internal innovation teams, and they're using tools like design thinking and lean launch to enable cross-functional groups to come together and put forward problem sets that then are become places where people can try and put forward solutions and hopefully innovations. And those solutions might come externally or they might come internally. Arjun mentioned the NSF, and one big point of that is these user-generated needs. And so one challenge that we often have are entrepreneurs with inventions in search of solutions. And on the other hand, we have problem sets in search of solutions. And that's really what we want to try and get towards, is better understanding what are the real legitimate problem sets that our industry and our business ecosystems are having, and how can we put effectively together teams of researchers or small businesses, student groups, to go after that and leverage the tools like SBIR, Arjun's money. I have Idea Advance money. Other WDC has some funds to really be proactive in addressing these key challenges. And I guess the other thing too is that, sometimes we are very limited to thinking that innovation is technology, but there are innovative policies, there are innovative activities that can be really helpful to moving the business forward. And so finding inclusive ways through maybe these working groups or other mechanisms where not just the technologists get to put forward their problems, but other elements of your business get to work on these big key problem sets. And so, as I've said, like AmFam has done this, Northwest Mutual has done this to put forward these kind of innovative design thinking work groups. And so there are resources out there to kind of help your business think about that as well. But those are some practical ways that I've seen that done.
Mm-hmm. I want to give everyone else a chance. And maybe just a comment. One of the, I'm not giving away too much. One of the programs that we've utilized at the University of Minnesota's Tech Transfer Office is a reverse pitch competition where industry comes and presents to the university saying, I have the following problems we want to solve. And then the tech transfer arm aligns different researchers to try to address some of them. I don't know if there's a similar program in Wisconsin.
We've definitely done that kind of thing, and it looks like Adela's shaking her head, and they've
yeah, we're doing something similar with the Air National Guard. Wharf has something similar with the challenge. Milwaukee has something similar. So, but the process is done a little differently in each one, and that's fine.
Yep.
And I saw in the Q&A that the comment that 55 or 50,000 is minuscule. I couldn't agree with you more. And I understand the idea of the internal structural, corporate research support. I mean, I think that's not a question for us. I mean, we certainly agree with you that if you can identify a problem and then identify, major funds towards that. My point is that we have mechanisms to engage internally to the system, faculty members in thinking about problems that might be valuable for industry. And so we need to kind of continue to think about how to leverage that with additional dollars, because I think that you have a willing audience there, and you have, like Eric's group, and we have groups like that throughout the UW system, and using that kind of reverse pitch idea of providing, ideas of here are some areas that need to be solved. I think we can put a lot of interesting work in front of our faculty and our students.
I'll
Okay.
just add to the 55,000 being a small amount. It is absolutely a small amount. But I wonder sometimes if we can break up a project into value-added milestones and inflection points. I see this a lot when we do our work with our biotech companies. We have a company, Stratitech, that's kind of a home run out of Madison, getting something like, it was like a skin grafting technology. So getting something like that into market is a multi-million, decades-long project to get into market. But they leveraged tons of SBIR dollars. They wrote grants that could fund, 4 or 5 different elements of the project. They had DARPA, they had NIH, they had other components of DoD fund various aspects of it. And so over time, the money really helped, I think, to the tune of like $300 million or something like that of non-dilutive funding that they earned over the course of time to develop this technology. So it's not the answer for everybody, but it's something that we see a lot at SBI in our CTC world, is that incremental milestones and thinking, what can we do today to get to the next value added inflection point, and how can we use that money wisely can help you, get to the goal.
Yep. But thanks, everybody. I see we're just about at time, and I have a 4 o'clock as well. I just want to wrap up. There's a lot of need, a lot of and a lot of interest. And Arjun mentioned these regional innovation engines, which is a new program from the National Science Foundation. It's an opportunity to connect more across the region, across multiple states, and think about how we put those bigger investment dollars into innovation across a larger region. So I want to thank everybody. Do any panelists have any last minute comments or anything you want to add?
I just want to ask, what are you going to do with all the information that was presented today? Is there an action item, what to do after this, or this was just a conversation?
It was a good conversation, and what I would like to do is throw to Scott, and he can wrap things up and talk about where we're going next.
Yeah, thank you. And again, thanks to all the speakers and panelists. And to answer your question, Masood, so we're preparing a report as part of the project that we're working on with Rfid, and we'll be suggesting some next implementation steps. We know this is sort of a systemic issue. It's way bigger than one mill or one town. And so we expect to have some recommendations about what the region can do, what the state can do to help move some of this stuff along. Identified earlier some of the impacts immediately in Wisconsin Rapids in terms of job loss and economic loss. But we know the people who probably have suffered equally, if not more, are the timber growers and the harvesters. And we have this great resource. And I'm really, really excited about what we've heard today about just a handful of the many growing technologies and innovations in the forest products industry. And it just seems like we should be able to embrace those and others to move forward, to complement our legacy industries, and to really make the use of that biomass in a sustainable and economically sustainable fashion too. So again, thanks everybody for coming. Just want to remind all the attendees that we will follow with an email with all the speaker information, the slides, and the registration list of everybody who is here, as well as a link of where you can find the recording so that you can share this with other folks. We also have a project website that the city is hosting that you see here at the bottom, where you can find additional information And when we do release our reports, we'll maybe get that out too and let folks know that that's available as well. So again, thanks so much to everybody for participating and attending today. Great, great conversation, great presentations, and have a great rest of your evening.
Thank you, everybody. Have a great day.
Thank you.